What is the measure of a major business corporation today? At General Motors, we think success is measured by how well we operate between the customer's interest and the stockholder's interest, always taking into account all responsibilities to the public at large. We meet our responsibilities to our customers with products they need and want, built and tested to a high level of quality, with safety features designed in at prices they can afford. At General Motors, we have seen widespread acceptance of our products by our customers. This has happened because we are constantly seeking to improve on what we have done before, searching for ways to provide more comfort and convenience, striving to design in the greatest value possible, introducing new models with features that meet the changing desires of the driving public. To us, this is simply doing our job. A major concern has always been the safety of the people who drive our cars. This has been a primary and continuing objective since we built our first cars in 1908. Today, we use sophisticated research equipment, such as driving simulators, to help engineers design in safety right from the very beginning. Our designers never forget that people drive our cars, big people and little people, people of different moods and temperaments, people who are always alert when they're behind the wheel, and people who aren't. We are constantly working to design and test features that will provide them a greater measure of safety inside the automobile structure itself. For years, we have been studying what happens inside our cars in crash situations. At our Safety Research Center, where GM has consolidated and coordinated most of its indoor safety operations, we have built 2 impact sleds for simulating crash tests under repeatable conditions. These cars are heavily instrumented, so the impact forces can be scientifically measured. Velocities can be varied as desired. This kind of testing helps us improve the design of restraint devices and interior configuration. It has helped us in the design of special safety carriers for infants. It is currently helping us in our intensive work to develop an airbag that will inflate automatically upon collision to cushion the passengers against impact. Safety at General Motors begins right at the drawing board, in the design of the frame, the wheels, the brakes, the suspension system, in each of the 14,000 parts that make up a modern automobile. Before the design of a part is approved for production, samples are subjected to hundreds of hours of laboratory testing. This testing is designed to duplicate the use the part may be expected to meet in actual service. It's going on today, right now, in dozens of General Motors laboratories around the United States. Laboratory testing is only one part of the test program that individual components undergo. Parts are assembled into cars and subjected to test driving at our 4,000-acre proving ground in Michigan, our 2,538-acre test facility in Arizona, and wherever else GM engineers may decide to go to get the data they need. In 1969, GM cars were driven 70 million test miles on proving ground roads and public highways. When new parts survive testing like this, the chances are excellent they will hold up well in actual service. To be sure, we put the first production cars through the same kind of rugged test program. Many of the facts our engineers seek can be obtained only by deliberate destruction of test vehicles. Many cars are consumed by this program every year. Our investment in proving grounds, testing facilities, and scientific and engineering personnel is all actively engaged in what we believe is the most extensive safety research program in the world. This is what must be done to obtain the data we need to help us build greater safety into our products. By feeding the test information into computers, we can analyze it quickly, then see that it is shared with safety specialists throughout the corporation and with the government as well. When a new feature is tested and proved, it is incorporated into actual production cars. The traditional model change permits such new developments to be made available to the public at the earliest possible time. General Motors is proud of the many safety features conceived by our design and engineering people. Many were introduced before any government standards were even considered and have become commonplace on all cars today. The energy-absorbing steering column is one example. It was introduced over a year before any government standards for steering systems were adopted. Another is the steering column lock that simultaneously locks the ignition and steering wheel and prevents the transmission from being shifted into gear. This contributes to vehicle safety because 1 out of 6 stolen cars is involved in an accident. It was introduced a year ahead of a government standard. Still, another important safety feature is the side impact bar, introduced by General Motors in 1968. This helps reduce penetration by a vehicle striking from the side. Government standards for side impact are just now being set. They are but 3 of the great number of accident prevention, occupant protection, and anti-theft features on GM cars today. They help explain why the highway fatality rate per miles driven is less than 1/3 of what it was 40 years ago. GM's safety research is not limited to the automobile. Our proving ground facilities provide our engineers excellent outdoor laboratories for the study of highway design. For years, they have been investigating such things as roadside light poles that give way without major damage to car or passengers, guardrails that do a better job, improved materials for road surfaces, safer highway plantings, proper speed limits for various types of open roads and for access ramps. The more of this kind of fundamental research, the safer our highways become. In addition to maintaining facilities at our own Safety Research Center, General Motors has joined with other automobile manufacturers in supporting and contributing to the Highway Safety Research Institute, an independent organization at the University of Michigan that seeks to provide basic research in vehicle and highway safety. We have also made grants totaling several millions of dollars to support highway research by leading universities in New York, Michigan, California, and the Highway Users Federation through the Automobile Manufacturers Association. We take pride in providing leadership and support in an area so important to our customers. A measure of the success of any manufacturer of complex products is how the transition is made from individual hand-built components to parts that are mass-produced by the hundreds of thousands. These parts must be assembled into production automobiles that meet the same high standards of safety and durability as the test vehicles. Obviously, there are many opportunities for defects to occur in the manufacture of a product as complex as an automobile, but the goal throughout is to see that they are kept to an absolute minimum. Our production methods are aimed at preventing defects from occurring. They include quality control inspections at nearly every step along our assembly lines. Every day, as a double check on our comprehensive assembly line inspections, we select at random a number of new production automobiles and run them through what we call quality audit departments. These are modern scientific test chambers where important elements of automobile construction and operation are checked by experienced inspectors and sensitive electronic test devices. Any problem discovered here can be traced back to its source on the production line and corrections made. Today, as always in our production process at GM, the effort goes on to prevent problems before they occur, to correct those that do occur, and to find and eliminate the reasons for them so they won't occur again. It's a never-ending cycle that seeks to assure our customers products of the highest possible quality. Of course, we recognize the constant challenge we face to maintain the high standards we set for ourselves. We can never be satisfied with the status quo. The dynamic nature of today's competitive society demands innovation and change. Our research scientists and engineers are looking ahead to the future, experimenting with new ideas and concepts that may one day appear in our products. This is a never-ending quest with us and is one important reason General Motors has been the industry leader for so many years. We recognize that there is another and broader facet to meeting our responsibilities. We are all aware of the consequences facing the human race unless the pollution of our water and air is halted. The problem requires the attention of every citizen. But leadership is needed, and it must come from those who have knowledge and resources. Long ago, General Motors joined other concerned business and government organizations to accept this leadership. For nearly 20 years, General Motors has been concerned with the growing problem of pollution. And we were doing something about it long before the problem became a national concern. Our smog research chamber was the first of its kind in the industry. Here, a mixture of air and exhaust is circulated in artificial light, matching that of the sun on a clear day at high noon. This facility has greatly aided in expanding our knowledge of air chemistry. We have said that we are committed to solving the air pollution problem as far as our automobiles are concerned. As a measure of our commitment, we expect to spend $113 million in 1970 alone on automotive emission control facilities, research, engineering, and testing. We will not hesitate to use a power source other than the internal combustion engine if it solves the emission problem and meets the needs of our customers at a price they can afford. For years, we have been experimenting with cars powered by different types of engines. Our original experimental Firebird 1, displayed first in 1953, was powered by a gas turbine. In 1953, we powered a research bus with a gas turbine. In 1964, our experimental turbo cruiser bus was introduced. We now have another experimental turbine-powered bus designed for rapid transit. And in 1971, we will begin commercial production of a new gas turbine engine that will soon power General Motors trucks and buses. We are very open-minded about new power sources. We have research teams that have built working research vehicles propelled by steam, electricity, stored heat energy, a combination of gasoline and electricity, the Stirling engine, as well as the gas turbine. We have been aided in turbine engine research by our work with aircraft turbine engines. Some alternative power sources show the potential for lower exhaust emissions. None, however, is practical for automobiles in its present form. Even if mass-produced, cars powered by them would have to be sold at a price beyond most people's ability to pay. Steam, in particular, has attracted much attention. Steam engines are currently impractical as power sources because of the problems associated with the freezing of the working fluid and the deterioration of lubricants in the working fluid. Furthermore, current steam engines are too large and heavy to consider them for use by the general driving public. Meanwhile, our research into other power sources goes on. At the same time, our scientists and engineers have been making impressive strides toward their goal of eliminating pollution from cars powered by conventional internal combustion gasoline engines. The three major emissions are unburned hydrocarbons, carbon monoxide, and oxides of nitrogen, the same as with other power sources which burn petroleum fuels. GM scientists discovered that 20% of unburned hydrocarbons were emitted through the crankcase vent and 20% through evaporation of gasoline vapors from the fuel tank and carburetor. 60% escaped through the exhaust system, along with carbon monoxide and oxides of nitrogen, both products of combustion. In 1961, we introduced in California a positive crankcase ventilation valve to substantially eliminate the unburned hydrocarbons that were being emitted through the crankcase vent. The PCV appeared on all our new cars in 1963. We have since introduced two exhaust control systems. The AIR is an air pump that reduces exhaust emissions by turning the exhaust manifold into a kind of oxidizing afterburner. Our controlled combustion system heats incoming air for better fuel metering, along with modifications to the combustion chamber and other engine components. Last fall, we introduced a system to control fuel evaporation on 1970 cars sold in California. It vents fumes from the gas tank and carburetor bowl to a charcoal canister. When the car is started, the fumes are fed back to the engine to be burned. It will be installed nationwide on all our 1971 cars. In addition, we are looking into further modification of engine design, improved control systems, and possibly fuel injection for more precise air-fuel ratios. This kind of effort has already caused the total emissions of the three primary automotive pollutants to be significantly reduced. These bars represent the emission levels of pollutants from 1960 vehicles without controls. With the installation of an evaporative control system on all 1970 GM cars sold in California, a system to be installed nationwide on all 1971 GM models, hydrocarbon emissions are reduced by 80% and carbon monoxide emissions by about 65%. Oxides of nitrogen will also be reduced. By 1975, we will have taken another significant step toward automobiles that will be virtually pollution-free. This is truly a remarkable achievement when you consider that only 20 years ago, no one knew how to measure most of the pollutants discharged into the air, much less control and eliminate them. We have also developed a package of engine modifications and maintenance requirements to reduce exhaust emissions substantially from older cars with no exhaust control systems. At the present time, the lead in gasoline leaves deposits in emission control devices. But now that broad-scale availability of unleaded gasolines of 91 research octane number has been promised, we believe it will be technically feasible to develop long-life emission control devices such as exhaust catalytic converters, exhaust manifold reactors, and exhaust gas recirculation systems. Meanwhile, we have announced that all 1971 GM engines can operate on 91 octane gasoline. The New York Times called this announcement the most dramatic action by any industry in the new environmental movement. A new air pollution control facility in California has been made available recently to augment our already widespread research and test activity in this highly complex field. To help assure that our production cars meet emission standards, we have installed sensitive assembly line test equipment that measures the level of exhaust pollutants. Of course, we must never forget that an important factor in automotive emission control today is proper periodic maintenance by qualified service mechanics. General Motors operates 30 training centers around the country to help keep dealership service personnel up to date on the latest product features. This training includes maintenance of the emission control devices on our cars. These centers are modern laboratories where every phase of automobile repair and service is taught. Even independent garagemen can benefit from this learning, for we recognize that many General Motors cars are serviced at the corner garage or service station. These repairmen must be kept up to date on the latest service information. Thus, owners of General Motors cars must know that proper service and maintenance of their engines and exhaust system are available to them. We must depend on them to be concerned enough about pollution to follow prescribed maintenance schedules. Controlling industrial air pollution is another major goal at General Motors. Here, too, dramatic results have been achieved, especially in our foundries and powerhouses, where the problem is the most difficult to solve. Clearing up the problem requires a high level of technical know-how and very sophisticated equipment. In some facilities, we are using techniques such as high-energy scrubbers that trap more than 98% of particulate pollutants before they reach the atmosphere. At other locations, we have installed electrostatic precipitators to remove fly ash from coal-burning powerhouse stacks. There's no one way to do the job. It depends on each local situation. But the goal is the same, for all our plants to meet today's government requirements and standards and anticipate what will be required in the future. A similar effort is being applied to the control of waste discharges that might pollute our streams and rivers. Impurities in our water must be limited for public health and the avoidance of possible damage to nature's living things. For industrial organizations such as ours, the problems are considerable. Liquids are used in countless manufacturing processes for cooling, for lubricating, for coating, just to mention a few. Controlling the waste products from these processes takes a lot of scientific knowledge, careful planning, and a tremendous investment in equipment. But most of all, it takes the willingness to move ahead. General Motors plants have demonstrated that willingness over the years, long before industrial pollution became a national concern. It's just good business for them to try to conserve natural resources and reuse metals, chemicals, and liquids. Their continuing efforts to improve the environment are part of GM's responsibility as a good industrial neighbor in the communities where they are located. In 1970, our plants will spend $59 million on plant air and water pollution control facilities. Perhaps one of the most interesting techniques for treating air and liquid pollutants was developed by GM engineers for use at a Fisher Body division plant. Here, sulfur dioxide from powerhouse stacks is mixed with liquid waste containing chromate. The two pollutants react chemically and render each other harmless. The result is not only clean water, but clean air as well. Being a good corporate citizen has other facets too. We are acutely aware of the problems that are faced by our cities. A free flow of transportation is vital to the good health of urban communities. This can only occur when the system is properly balanced between different modes of transportation. General Motors has a long record of leadership in public mass transportation. We have urged consideration be given to improve travel on local streets, as well as high-speed highway access, to mass transit by bus and train, to rapid intercity rail travel. We are continually cooperating in all possible ways with federal, state, and local officials concerned with urban transportation. And we have appeared before a congressional committee in support of the proposed new urban mass transportation assistance legislation. To further this effort, our people are working on new concepts of small electric-powered commuter automobiles, experimental rapid transit coaches powered by gas turbines, high-speed trains, and even a new demand-responsive transportation system that provides taxi-like service at fares somewhere between those of a taxi and conventional buses. These vehicles and system concepts are assisting urban planners determine the appropriate mix of modes for each community. Many leaders in our plant cities are also trying to provide help for disadvantaged citizens. In one city, Pontiac, Michigan, General Motors has joined together in a partnership to provide more than $1 million in interest-free loans to a nonprofit minority group interested in inner-city housing. A similar loan has been made to a group in Flint. This concern with the well-being of the disadvantaged also manifests itself in our hiring policies. At the beginning of 1970, the number of GM minority employees was nearly 100,000. That is more than 15% of our total United States employment, a figure that exceeds the national percentage for minorities. We have hired more than 45,000 hardcore unemployed, and in 1969, we provided summer employment for more than 1,900 disadvantaged young people. As employees, these people become part of the large GM family, sharing the same benefits all our employees enjoy. They quickly learn that General Motors is concerned about their well-being, their safety on the job, their advancement as quickly as they meet standards of performance and achievement, their own personal development through a tuition refund educational program, and through corporate encouragement to take an action role in community endeavors for the betterment of all society. At the outset, we asked, what is the measure of a major business corporation today? Our answer is still the way we meet our responsibility to the people we serve, our millions of customers, our nearly 800,000 employees, our 40,000 suppliers, our 1,355,000 stockholders, and to the public at large. The problems of vehicle emissions, pollution from our manufacturing plants, the safety of the persons using our products, mass transit, social needs, these and many others are not new to General Motors. This film report serves to demonstrate some of the progress we have made in solving these problems. However, the job is not finished. Much more needs to be done. We recognize these needs. We understand our responsibilities. We have intensified our efforts. We will continue to dedicate our worldwide talents and facilities to solving these problems. We are confident our stockholders would want it no other way.